Hi, I am Rashani DeBell, and you are learning algebra. Hi everyone. In today's lesson, we are going to take a look at the zero and negative properties of exponents. So let's get started. Zero and negative exponents. Our objective is to evaluate powers that have zero and negative exponents. When you have a non-zero number raised to the power of 0, it is always going to be 1. Let's take a look at some examples. Negative 6 raised to the power of 0 is 1. 225 raised to the power of 0 is 1. A to the power of 0 is 1. If a number has a negative exponent, then take the reciprocal of the number. A negative exponent just means that the base is on the wrong side of the fraction line, so you need to flip the base to the other side. Algebraically, it looks like this. For any a to the power of n, if you have a to the power of negative n, then you're going to take its reciprocal and you are going to get 1 over a to the power of n. Notice that by taking the reciprocal, I've changed this negative exponent over here into its positive equivalent. And make sure that you never have a equal to 0, because when you have a equal to 0, then you have a number divided by 0, which we know in math can never, ever, ever happen. Numerically, here's an example. So you have 4 to the power of negative 2, which you take the reciprocal of 4 to get 1 over 4 to the power of 2. You can evaluate 4 squared to get 1 over 16. And now let's look at some examples. In this example, we are asked to rewrite with positive exponents. I'm going to start with the first one. We are given 3 times x to the negative 4th power times y to the negative 5th power. I'm going to start by separating out all of the terms so that I can see what is going on with each variable. So I have 3 times x to the negative 4th times y to the negative 5th. And then I'm going to evaluate each term. I have 3 to the power of 1, so I'm not doing anything to it because the 1 is positive. I have x to the power of negative 4. Since it's a raised to the power of a negative number, I know I've got to take the reciprocal of this variable, which means I'm going to flip it. So I'm going to have 1 over x to the power of a positive 4. Same idea over here. Y to the raised to the negative 5th power means in order to write a positive, I have to take the reciprocal of it, which is 1 over y to the power of 5, and that makes my exponent now a positive. Final step is to gather all of these terms together. So 3 times 1 times 1 is 3. This is over 1. 1 times x to the 4th times y to the 5th is x to the 4th, y to the 5th. In the second part, I've got 6d, the whole thing is raised to the power of negative x. Well, I can rewrite this as 6 times d, the whole thing raised to the power of negative x. Every time I have a parentheses, I'm going to distribute it, and if I don't see an exponent over here, that means it is raised to the power of 1. When I distribute, I've got 6 to the power of negative x times d to the power of negative x. Because my exponents are negative in both of these, I am going to take its reciprocal. So I'm going to flip 6, which ends up being 1 over 6 to the power of x. Take the reciprocal of d to the negative x becomes 1 over d to the positive x. And then combine. So 1 times 1 is 1. 6x times 6 to the power of x times d to the power of x is just going to be 6 to the power of x, d to the power of x. Alternatively, I could also recognize that this quantity, 6 times d, the whole thing is raised to the power of negative x. So I could use the same idea that I have to take the reciprocal of this entire expression and just take it, flip the entire expression. So I could also rewrite this as 6d, the whole thing raised to the power of x, which these two expressions are equivalent, so you could have either one of these. For part C, I have 1 over c to the power of negative 2x. Even though the negative is at the bottom of the fraction, the idea is still the same. I still have to take the reciprocal, so I'm going to take this 1 over c and flip it so that I get c to the power of 2 times x. Every time I take the reciprocal of a number, the exponent changes from its negative to the positive. In this final example over here, I have 5 to the power of 0. We know that anything to the power of 0 will always be 1. So that was our final answer for this part. In example 2, we are asked to evaluate the expression. In order to evaluate these expressions, we are going to utilize our knowledge of multiplying exponents, the properties of multiplying exponents, as well as the properties of zero exponents and negative exponents. So we look at the first example. We have 2 to the power of 4 times 2 to the power of negative 4. Since our bases are the same, I can go ahead and add my exponent. So I get 2 to the power of 4 plus a negative 4. 4 plus negative 4 is 0. And we know any number raised to the power of 0 is just going to be 1. For the second part, I have the quantity 3 raised to the power of negative 2 raised to the power of negative 2. Every time I see a parentheses, I need to think about multiplication, distributing this negative 2 with this negative 2 inside the parentheses. So I get 3 to the power of negative 2 times negative 2. 3 to the power of negative 2 times negative 2 gives me 3 to the power of negative times a negative is a positive. 2 times 2 is 4. I can go ahead and evaluate this. I know that 3 to the power of 4 is 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. In part C, we are asked to take 2 to the power of negative 6. Our exponent is negative, which means I need to take the reciprocal of this number 2. So it becomes 1 over 2. And when I take the reciprocal, this negative becomes a positive 6. I could leave this as is, or I can evaluate 2 to the power of 6, which ends up giving me 1 over 64. Finally, I have 1 over 9, the quantity raised to negative 1. Again, every time I see parentheses, think about distributing with every exponent inside. Both of these 1 and 9 have an exponent of 1, so this is 1 to the power of negative 1 over 9 to the power of negative 1. So I have to take the reciprocal of both numbers, and when I do that, I end up with 9 over 1, which I can simply write as 9. Here's an interesting fact. Say we are given a function of y is equal to 2 to the power of x. Notice what happens to the function when our values for x decreases. So we're going to evaluate it using a table, and I'm going to choose the values for x. So right here will be my values for x. Here I'm going to evaluate for each value of x. At x equals 3, I have 2 to the power of 3, which gives me 8. At x equals 2, 2 to the power of 2 is 4. At x equals 1, 2 to the power of 1 is 2. At x equals 0, 2 to the power of 0 is 1. At x equals negative 1, 2 to the power of negative 1 is 1/2, which is equivalent to 0.5. At x equals negative 2, I have 2 to the power of negative 2, which is 1/4, which is 0.25. At x equals negative 3, got 2 to the power of negative 3, which is 1/8, which gives me 0.125. At x equals negative 4, 2 to the power of negative 4 is 1/16, which is 0.0625. At x equals negative 5, 2 to the power of negative 5 is 1/32, which is 0.03125. At x equals negative 6, 2 to the power of negative 6 is 1/64, which is 0.015625. At x equals negative 7, 2 to the power of negative 7 is 1/128, which is 0.00788125. At x equals negative 8, 2 to the power of negative 8 is 1/256, which is 0.00390625. And at x equals negative 9, 2 to the power of negative 9 is 1/512, which is approximately 0.0019533125. First of all, notice that as my x values decrease, so I'm going from positive numbers to negative numbers, none of my evaluated functions is a negative. So I don't have, just because x is equal to negative 1 does not make it my evaluated function a negative 0.5. You'll notice that all of these values are positive. Also notice that as x decreases, my numbers are getting smaller and smaller, and we're getting closer and closer to 0, but none of these values are equal to 0. So let's take a look at what this looks like on a graph. At x equals 3, we are at 8. At x equals 2, we are at 4. At x equals 1, we are at 2. At x equals 0, we're at 1. At x equals negative 1, we're at 0.5. At negative 2, it's 0.25. At negative 3, 0.125. And as you can see, we are getting smaller and smaller and closer to 0, to the point it's almost difficult to graph these points. So you can see as our x values decrease, our graph gets smaller and smaller and gets closer and closer to 0, but never ever crosses the x-axis. We call this an exponential graph. And in later lessons, we'll also learn that the reason why it doesn't cross this x-axis is because of something called an asymptote, which is a floor that does not allow the graph to pass through it. And that concludes our lesson on the zero and negative properties of exponents. Thanks for watching.